All right, so wanted to do another con support video. This one is going to be on equivalent ratio word problems for you guys. So let's go through and see how they look. Let's go. So I'm going to zoom in a little bit so you guys can see a little better. Hopefully that's a little clearer for you guys now. It says Yoda soda is the intergalactic party drink that will have your friends saying, good this is. I guess that's the Yoda voice. Good this is. You are throwing a party and you need 5 liters of Yoda soda for every 12 guests. If you have 36 guests, how many liters of Yoda soda do you need? So the important part of any ratio problem is understanding your ratio, right? So it says you need 5 liters of Yoda soda for every 12 guests. So if you were to write that ratio out, right, what that means is you have 5 liters of Yoda soda, and you can write it out if you want the long way. And that is going to be related to, so you can put your double colon in there if you want, 12 guests. So 5 liters for 12 guests. All right. And anyways, so you can write your ratio out with your double colon, right? Or you can think about it as a fraction. Remember, it's the one on the left on top, the one on the right on the bottom, right? So what that just means is make sure you know what's on top and what's on bottom. So in this case, what we have on top is the liters, and on bottom you have the guests, right? So liters on top, guests on bottom. So this would be the same as 5 liters for every 12 guests. So this is your ratio, right? 5 liters for every 12 guests. And it asks you, all right, now that we know that's the ratio we're starting with, we want to figure out how many liters we're going to need, not for 12 guests, but for 36 guests. So it says if you have 36 guests, how many liters you need. So now you're going to change that denominator to 36, but we have to figure out the numerator that goes with it, right? So what is the value of x in this case? So you're just solving a proportion. You're asking yourself, all right, what is an equivalent ratio to 5 out of 12, basically? So 5 liters for every 12 guests is the same as x liters for every 36 guests. And in this case, we can look at the relationship we see on the bottom, and it's pretty easy to see that if you wanted to multiply the bottom by 3, you could get the equivalent denominator, right? So you have 12 times 3 is 36, so that's the relationship you're going to use. And since we're trying to create equivalent ratios, whatever you do at the bottom, you have to do the top. So you're going to multiply top and bottom by that very same 3, right? Because 3 over 3 is a value of 1. So 5 twelfths times 1 is still a value that's equivalent to 5 twelfths. And ultimately what you end up with is 5 times 3, which is 15. So the answer here is if 5 liters of soda for every 12 guests, then for 36 guests you would need 3 times that amount, or you need 15 liters of soda. So that's what you put, 15 liters of Yoda soda. And that's how you do the problem. So over here we just type in 15, and we're good to go. Okay. For the next problem, number 2 here, says Stefan, number 2. Stefan is making meringue with eggs, egg whites, and sugar. He uses 50 grams of sugar for every egg white. So 50 grams of sugar for every 1 egg white. If Stefan uses 10 egg whites, how many grams of sugar does he need to use? So I think we can just jump directly into the fraction here. So make sure you know what's on top and what's on bottom. It doesn't really matter which one you put on top and bottom as long as you're being consistent with it, right? So the category of thing that we're going to put on top is going to be grams of sugar. So I'm going to put grams of sugar on top. Remember, ratio is just a comparison of any two things. So the thing I'm comparing is to start with grams of sugar on top and the number of egg whites on bottom. So I'm going to put egg whites on bottom. So here we have grams of sugar on top, egg whites on bottom. This is our ratio that we're setting up, grams of sugar to egg whites. And then all you got to do is replace the grams of sugar with the known value. So he says he uses 50 grams of sugar for every 1 egg white. So that means 50 grams of sugar for every 1 egg white. All right, there we go. And then we're trying to figure out, Stefan uses 10 egg whites. How many grams of sugar will he use? Well, now he's changing the denominator not from 1, but to 10, right? We're using 10 times as many egg whites. I was going to need 10 times as many grams of sugar, right? So obviously x is just going to be 10 times 50, right? But you guys can see that process. So what would you multiply 1 by to get the 10? Obviously times by 10. So then what do you multiply the top by? Times by 10. And you can see that he will need 500 grams of sugar, right? So it says, how many grams of sugar does he use? 500 grams of sugar would be the answer. And now you're going to just put that in here, 100. It's easy as peasy. Okay, then we do the next problem. So our next problem is, Omar has a new credit card. He earns 300 reward points for every $100 he spends. If Omar earned 1,800 reward points, how much money did he spend? So once again, what's your category on top? What's your category on bottom? In this case, we're going to do reward points on top. And we're going to put money spent, right? Dollars spent on bottom. So this is your ratio, reward points to dollars spent. And as long as you're consistent, reward points go on top, dollars spent go on bottom, you're going to be just fine. So it says he earned 300 reward points for every $100 spent. So it's 300 reward points for every $100 spent, basically a 3-to-1 ratio, right? So it's just the reward points is 3 times the number of dollars spent. It's pretty simple. And so if Omar earned 1,800 reward points, how much money did he spend? Well, we're going to change the numerator to now 1,800, right? Because the reward points increased to 1,800, not 300. And the amount of money he spent is the unknown, the thing we're looking for. And once again, just look at the relationship. 3 times 6 is 18, right? So this is going to be times by 6, because 300 times 6 is 1,800. If you times the top by 6, you better times the bottom by 6. So there you go. What's 100 times 6? $600. And like I said, it was a 3-to-1 ratio anyways, right? So what's 1,800 divided by 3? That's going to be 600, right? So either way, you're going to get 600. So he spent $600. That's how much money he spent. So you're right, $600. All right. Let's do the next problem. So the next problem says, according to Greg, perfect cherry pies have a ratio of 240 cherries to 3 pies. So that basically means that if it's 240 cherries for every 3 pies, then the simplest form of that ratio would be that it is 80 cherries for every 1 pie, right? But we'll just leave it as it is. So we're going to put number of cherries on top. We're going to put the number of pies on bottom, cherries to pies. And that means that cherries, and he says perfect ratio would be 240 for every 3, which obviously is the same as 80 for every 1, right, if you wanted to think about it that way. And then it says for 9 pies, what will it be? Okay, so then we're going to change the denominator to 9 pies, and then what would the number of cherries be? So we obviously know the answer is 720, but if we were going to go about the process just like we always do, what would I multiply 3 by to get 9? You multiply 3 by 3 to get 9. So what's 240 times 3? It's going to be the answer. What's 3 times 200? 600. What's 3 times 40? 120. So what's 600 plus 120? 720. So I need 720 cherries in order to get the perfect ratio for 9 full cherry pies. So that's it. So 720, and that's how you do these problems. So the only important part here is to make sure you realize what the category on top is, what the category on bottom is. Make sure that category stays consistent, right? So if it's cherries to pies, cherries are on top, pies are on bottom. That's it.